Today, we're going to talk about Lewis structures. We're going to discuss how to draw them as well as how to identify their formal charges. Here are a set of general instructions which you can follow to create the Lewis structure for any molecule. Keep in mind that the steps may vary due to the simplicity or complexity of certain molecules. Now, you have the chance to stop the video, read the question through, and try and solve the problem yourself. Here's the answer so that you can check and see if you got the question correct. Now, let's go through part A of the problem together. We're given the molecule iodine monofluoride, which has one iodine atom and one fluorine atom. Our first step is to identify the total number of valence electrons in the molecule. A valence electron is an electron in the outermost shell of an atom. You can find the number of valence electrons in an atom by looking at its position on the periodic table of elements. We know that there are 7 valence electrons in iodine and 7 valence electrons in fluorine. To find the total number of valence electrons, we add both of those up, which would be 7 plus 7, which gives us a total of 14 valence electrons to work with. Our next step is to draw one line between the two atoms, like this. This represents our single bond, which can be doubled up or tripled up later if necessary. This represents 2 valence electrons, so now we've used 2 of our available 14 valence electrons, and we have 12 more to work with. We're going to put those 12 electrons around each of our atoms to fill their octets. Now we've used all 14 of our available valence electrons, and we can double check to make sure that our Lewis structure is complete by checking and making sure that the octet rule is fulfilled. To do this, we look at iodine first, 2, 4, 6, 8 electrons, 2, 4, 6, 8 electrons in its octet, because recall that a single bond represents 2 shared electrons between 2 atoms. Our Lewis structure for iodine monofluoride is complete. Our next step for this molecule is to identify its formal charge. A formal charge table, as shown here, allows us to set up our information and quickly do our math. We often use the abbreviations VE for valence electrons, which is the number of electrons in an element's outer shell, AE here, which stands for assigned electrons, which is the number of electrons the atom has after bonding, and FC, which stands for formal charge, the charge assigned to a molecule or atom after bonding. The assigned electrons are subtracted in this row from the valence electrons in this row to give us our overall formal charge in this row. To do this, we must first identify how many valence electrons we have. Recall that in part A of the problem, we identified that there are 7 valence electrons in both iodine and fluorine, which we can put into the top row of our table. Next, we need to identify how many assigned electrons each atom has. To do this, we first split our single bond in half and recall that there are 2 electrons in this bond. When we're looking at assigned electrons, each atom sharing the single bond gets assigned 1 electron. Now, we're going to look at how many assigned electrons there are for each atom. So in iodine, there are 1, 2, 3, 4, 5, 6, 7 assigned electrons. So we can write that in. And in fluorine, there are also 7 assigned electrons. 1 from a single bond, 2, 3, 4, 5, 6, 7. So we can write that in and fill that into our table. Now, our next thing is we're going to imagine that there's a subtraction sign here. So we have 7 minus 7, which gives us 0. Again, same thing on this side, 7 minus 7, which gives us 0. So iodine has a formal charge of 0, and fluorine has a formal charge of 0. Now, to look at our overall formal charge, we add both of those up, which would give us an overall formal charge of 0. When we look back at our initial molecule here, IF, we notice that there's no plus sign or minus sign here, which means our formal charge for iodine monofluoride is 0. And so we correctly identified our formal charge for our Lewis structure. Now, you can take the chance to stop the video once again and attempt part B of the question for iodine trifluoride. Now you can check and see if you got the question right. Now, let's go through part B of the problem together. Our first step will be to identify the number of valence electrons in each atom. Recall that in part A, we identified that there are 7 valence electrons in both iodine and fluorine. Our next step will be to add all of them together to find the total valence electrons, which would be 1, 7 from our 1 iodine times 3 times 7, which because there are 3 fluorines, which gives us a total of 28 valence electrons to work with. Our next step is going to be to identify which atom to use in the center. This is an important step since the molecule we're looking at involves the bonding of more than 2 atoms. To do this, we need to identify which atom is the least electronegative. It also helps if the center atom has the ability to have an expanded octet, since that'll help us later, but that doesn't necessarily apply to all Lewis structures. Iodine is found in period 5, group 17, where fluorine is found in period 2, group 17. Since they're both found in the same group, we're going to look at their periods. Iodine is found lower on the periodic table, and that means that it has a lower electronegativity than fluorine does. That means that fluorine pulls its electrons in slightly tighter than iodine does. So we're going to use iodine as our center molecule. Our next step is to draw one line between each atom. This uses 6 of our available valence electrons since we used 3 single bonds, each using 2 electrons. Our next step is to add our remaining electrons to each of our outer atoms, which is all fluorine atoms. 6, 12, 18. So now we've used another 18 electrons, but we still have 4 left. So now we need to look at our center atom. This is where our expanded octet is important because we have 2, 4, and 6 electrons already in iodine's octet. If we add 4 more, that means it would have an octet with 10 electrons, not 8. So is it okay if we do this? Yes, it is okay that we add all 4 electrons to iodine. We know that iodine is found in period 5 of the periodic table. Elements in period 3 or greater can have an expanded octet. Therefore, iodine can have an expanded octet and can take the extra 2 electrons to have 10 electrons in its octet. This is because it has access to the d orbital, which not all atoms have access to. Now we can add those extra electrons. 1, 2, 3, 4. Now we've used all 28 of our valence electrons and our structure is complete. But first, let's check and make sure that all atoms have a complete octet. This fluorine has 2, 4, 6, 8. This fluorine has 2, 4, 6, 8. This fluorine has 2, 4, 6, 8. And this iodine has 2, 4, 6, 8, 10. And that means our Lewis structure for iodine trifluoride is complete. Our next step is to identify the formal charge for the molecule iodine trifluoride. Recall that we identified the number of valence electrons in each atom at the beginning of this problem. Both atoms have 7 valence electrons, so we can add that to the top row of our table. Our next task is to identify how many assigned electrons each atom has. So once again, we'll split all of our single bonds in half to remember that each atom gets 1 electron assigned to it. And now we're going to go through and we're going to identify the assigned electrons for iodine. So we have 1, 2, 3 from single bonds, 4, 5, 6, 7. So iodine has 7 assigned electrons. So we can write that into our table. We can quickly do our math to do 7 minus 7, which gives us 0. Next, we can look at our fluorines. All 3 of these fluorines have the same bonding, so all 3 will have the same assigned electrons in our row. So we're just going to look at one of them right now. So 1 from single bonds, 2, 3, 4, 5, 6, 7. So we can write that into our table. So fluorine has 7 assigned electrons. And since all 3 of them are the same, we can write that for our entire row. And now we can do our math, our subtraction. And we know that 7 minus 7 is going to be 0 every single time. Now, our next step is to identify the formal charge for the entire molecule. So recall that to do that, we add up our formal charge from each individual molecule to give us a total of 0. And we know that this is accurate since our given name here, iodine trifluoride, has no plus sign and no minus sign. It has nothing here, so that means its formal charge is also 0, meaning we correctly identified the formal charge for this Lewis structure. Now, this question comes from the section 4 of our LibreText here at Thompson Rivers University. There you can find this question as well as many other great questions to help you test your knowledge on chemistry.